Hey guys, I'm just doing this question 8 that Victor has asked me to do. It's just here. If you need a copy of it, it's on the Facebook page. I'm not sure what year it's from, but Part B corresponds to Part C, so we had to do Part B first. This is an integral inequality. So it's one of the really difficult inequalities that we talked about, and it uses integration actually to show these two things. You'll notice there's some e's in here, and the 1 on x there should integrate for a log. But anyway, I'm giving a little bit away. Let's have a look at what I've done. So, the question asked us to prove this, that e to the power of negative n over n minus 1 is less than 1 minus 1 on n to the power of n, which is less than e to the negative 1. Now, it's double-barreled here, and then the 2 on the outside. So what I'm going to do is I'm going to compare areas. Now, I'm using my trusty colours here. The first area I'm going to find is this one. And that's a nice, easy, simple block. Okay, so the area of that is just going to be base times height. The other block I'm going to pick is this one. Now, I'll talk to you about why I'm doing that. And A2 is going to be this block here. You'll notice, in fact, this is where these integral inequalities come from, is that we can find the area underneath this curve exactly, but what we know for sure is that this rectangle here is definitely smaller than that area, but this rectangle here is definitely larger. One that is smaller and one that is larger. So, I mean, the question set it up for you a little bit as well, but that's definitely where we're going to go. So A2 is going to equal base times height as well. I won't bore you with the details about the exact widths here, but that height, y1, if you like, remember that's the function y equals 1 on x, for this here is going to be, y1 is simply going to be 1 over n, whereas here y2, the height, is going to be 1 over n minus 1. The distance between them is going to be 1, so that's nice and easy. It turns out that a1 just is 1 on n, and a2 is 1 over n minus 1. So, where that goes is basically to this. The area A1 must be less than the integral of 1 on x dx between the limits of n and n minus 1, which also has to be less than A2. Filling that in is just like this. 1 on n is less than this one here. So we've got those, and then we just do our amazing powers of calculus to sort of get us very close to what we want. That's the log, obviously, of x. X is we're in the first quadrant here, so we don't have to worry about absolute value or anything like that. We can just say that's the log of x. We're going to evaluate it between n and n minus 1. That's still going to be less than 1 on n minus 1. Now we use our incredible powers of mathematical magic. We end up with the log of n over n minus 1. So 1 on n minus 1. Now, for those of you observing, that's actually not what we want. We want that. Now, hopefully, most of you can see there that we're going to take the log, the exponential, rather, of everything there, which should get us very, very close, but we've got an n, okay? This is not the same as this, and we've got some negatives. I think the really easiest part, the easiest part here is going to be those negatives. But we've got to remember with our inequalities. So I'm going to multiply everything by negative 1, which gives me this. Now from here, we've got a negative, we've flipped the inequality signs, we've got a negative out the front of the log, so I'm going to just flip the log instead. For those of you playing at home, you should realise that's 1 over 1 minus n, which is what we want. There is another problem though. I do end up with a to the power of n. Now, because that's a log, if I had multiplied that by n, we'd be okay. So I'm actually going to multiply everything by n. If I do that, now that's remarkably close. I do have my inequalities around the wrong way, but what I can do is just flip them over and end up with pretty much what I want. I'm going to take the n up. I'm going to do a couple of things in this step. I'm going to take the n up here as a power. I'm going to switch the inequality sign. You can probably see where we go from there. You get this. So I'm going to take this over to this side and that over to that side. So I end up with negative n over n minus 1 is less than the log of n minus 1 on n to the power of n, which is less than negative 1. Take e to the power of or write it like it wants us to write it, as required. So that's a fairly decent jump. 2 marks. You can have a look through there. The mathematics isn't necessarily very difficult. In fact, in terms of inequalities produced by integrals, that's actually a pretty easy one. It's fussing around with it until you get what you want that can prove to be a little bit tricky. So the first part, that's a nice little inequality that everybody, people who write 4-unit tests absolutely love.